Everybody, thank you for the introduction. Really appreciate and excited to be giving everybody this short presentation about, hey, is your cloud environment secure? Okay. We're going to go over some general rules. We're going to talk about what the cloud is, and then we're going to go into Jesse's top tips for making sure that your cloud is secure. Okay. So we have a couple of different presentation slides to go through, and feel free to spin up any questions on the chat as I'm talking. I don't mind taking a brief pause and talking about things further, or even trying to answer questions if possible. So here we go. Just a little bit of background, Compass IT clients, we're based out of North Province, Rhode Island. We do work all over the world. Been in business about 10 plus years, and basically we offer all different services regarding compliance, security services. So if you're interested, find us out on the web or email us after the fact. Okay, so the cloud, right? That's the cloud right there. That's it. That's everything in the cloud. That's pretty much an accurate representation of the cloud right there, if you think about it. It's not really the big mystery that everybody kind of thinks it is. It offers a lot more stability, resilience, and flexibility to the modern computer world. But the cloud has always kind of been there. It's just evolved, right? I mean, even if you think back to basic terminal banking applications where it would contact up into a big data center, right? I mean, it's still kind of the cloud. It's just that the main difference here is when the cloud is hosted and managed by somebody else completely, and there's just so many more different services that are layered on top of it now. So a little bit of we're going to try to discuss, the history of the cloud. Maybe do a little interesting tidbits. Does anybody know who coined the term cloud computing? It's a topic, a matter of debate, right? So it really kind of depends on if you mean the cloud as it exists today, right? So there were hints of cloud computing first being used by Compaq. Anybody remember Compaq? Later bought by HP. So Compaq originally spun up services, and their term for cloud was basically, not the modern version of the cloud today, but basically selling servers to internet service providers, saying, hey, that's our cloud strategy, right? And that's obviously not the cloud that we have today. And I don't think that strategy worked out too well for Compaq because, they're not really in existence anymore, right? But there are earlier business plans of where this term was actually used in cloud computing was actually used at some certain meetings. If you look back a little bit further, a little bit forward, I should say, 2008, Dell tried to trademark the term, which is pretty shady, right? Like you can't really trademark that term. It's kind of also like how I always kind of found it interesting when Android phones first started coming out, and everybody found out that George Lucas had a patent on the term droid, right? Because basically he was the one who used it in the Star Wars movies. So kind of funny that people could actually, try to coin phrases or trademark phrases. Obviously, Dell was not successful because everybody uses the term cloud computing. But if we kind of want to really get into it, Mr. Eric Schmidt here referenced cloud computing in August of 2006. Basically what he said was, what's interesting is that there's an emergent new model, Schmidt said. I don't think people have really understood how big the opportunity really is. It starts with the premise that data service and architecture should be on servers. We call it cloud computing. They should be in the cloud somewhere. And that's kind of like the model we're in right now. So I know everybody on here is like some sort of security professional or auditor or something of that nature. But basically, you guys should all be familiar with the Nist framework, right? And so I'm going to kind of be using this to lead the conversation into how do you secure the cloud, and I'll kind of go over my thought process on it. But the NIST has so many different publications that they have their own publication for a definition of what cloud computing actually is. So, if we go through the explanation from NIST, we see that it's kind of what Eric Schmidt was just really kind of talking about, right? It's a pool of configurable computing resources that includes everything, right? Networks, servers. We see that was pretty much the first phase of it. Storage, applications, and services. Now, I mean, we're on an example of software as a service during this conference, right? But, I mean, obviously Zoom is a software as a service. We don't have to worry about the use of Zoom. We don't have to, well, I shouldn't say that, right? Zoom had its issues, but we don't have to worry about maintaining Zoom for ourselves. We don't build on Zoom. We just use Zoom. We're the consumers of Zoom, right? And that's just software as a service. So, and it exists in the cloud today. The concept of Zoom and even internet and video calling wasn't even a thing really in, the early 2000s. Maybe it started coming out around 2005, I think. I'd like to say, Skype started getting some traction, things like that. But software as a service really started coming out in the past 10 years, you would say, right? So with the cloud model, with the NIST definition, there's 5 essential characteristics, 3 service models, and 4 deployment models. Again, it's important I'm covering this, and it might be something that people have heard in the past, but it's important to, understand what the cloud is composed of before you could really kind of take steps to configuring it and procedures to configure the cloud. So the characteristics are on-demand self-service, right? So a consumer can utilize provision computing capabilities such as service time and network storage as needed automatically without requiring human intervention with each service provider. So that's interesting, on-demand self-service. So if you think back before the cloud was really a thing, you think back, 10 years ago, 12 years ago, if you wanted to provision network storage, or if you wanted to set up a network share or something, like if you wanted to provision servers, right, you'd have to put in a request. You would have to have technicians on site to build up this server for you, get it configured, make sure it's all set up and running. Now with the modern cloud, it's really a matter of a couple of clicks, right? You get onto your cloud portal, you pick what template you want to use, you click through, and within about 5 minutes, depending on the template or resources you use, you have a brand new server sitting there and available for you. The second characteristic is broad network access. Again, Zoom is another great example of a cloud type of platform. We access Zoom over our mobile phones. I was driving the other day and I realized I was late to a meeting, and I had my phone plugged in, and I had the Zoom app on my phone and my CarPlay service. So it was right on my my dashboard, and basically I didn't have my camera on, obviously, but if I had, maybe I could mount a camera and just go on road trips all day. But it made it widely available, right? So the cloud's characteristics: broad network access, accessible from anywhere really where you have network access, right? Resource pooling. The resource pooling is kind of, we don't really see all the back end of the cloud and how it's handling things. That's really the responsibility of the cloud provider, but they basically make it so that, even though they say that, oh, hey, no, you're on your own instance, in the background, it's all running from the power from that one particular data center or groups of data centers, right? So we don't have any control over that. And, that might be a good thing, right? We have to entrust that those cloud providers are, segmenting out controls enough. They're providing us with the resources we signed up for, and that, that they're going to keep the services up and running as effectively as possible, right? So rapid elasticity, this is kind of cool too, because if you think about before cloud computing, before virtualization as it exists today, you bought a server, right? And say you wanted to add resources to the server. Well, that means what? You'd have to shut it down for maintenance schedule. You'd have to buy the correct hardware that's compatible with it, right? You would then have to bring the server back up, test to make sure that hardware is working and configured properly, and all said and done, that's all has to be done after hours by a human, basically doing physical work. Well, nowadays, you basically have the ability to say, oh, hey, I need more RAM on this, or even the systems now have conditions in place, right, where if they see X amount of resources being consumed, they raise up the level to adjust the processing power, the memory, the speed of the machine itself to compensate. So another thing that's been made available from the cloud, and that's why it's characteristic of the cloud. So measured service, cloud systems automatically control and optimize resource use by leveraging a meter capability at some level abstract appropriate to the type of service. Resource use can be monitored, controlled, and reported, providing transparency with both provider and consumer of utilized service. So when you talk about the cloud resources, right, you're paying for that, right? So, and it's usually based on, well, different cloud providers do it, different models. It could be provided hours used, hours with resources consumed, space. So there's a bunch of different factors, but it's certainly a measured service. Whereas if you had old hardware that you had provisioned at your own facility, the thing you're really kind of paying attention to as far as utilization is the maybe electricity costs and heating and cooling, right? So deployment models, there is something in here that I kind of cut out only because some of these terms, if you think about it, they don't really work in the modern infrastructure, but Nist still has these defined. The public cloud, cloud of shares is provisioned for open use by general public, maybe owned, managed, or operated by a business, academic, or a government organization, or some combination of them exists on the premise of the cloud provider. So that's something that's there. It's available for us to use. Private cloud, it used to be that the private cloud, you'd be like, oh yeah, I set up my own private cloud, right? I kind of feel like that term has maybe gone by the wayside, and it's, I don't know if it's necessarily, I guess there are some cases where, I'll cover them a little later. There might be something where you have true private instances for security reasons, like when you talk about governments and things like that. But usually that's used to meant for a single use, right? By a single organization. Cloud infrastructure, community cloud infrastructure provision for exclusive use by a specific community of consumers from organizations that have shared concerns. So in that type of model, you might have a partner company and you guys work together, or there's two different entities that are working together towards a common goal, maybe development of, say, like the coronavirus vaccine, and then you guys are usually shared resources out there. And finally, the hybrid cloud. Hybrid is where you kind of merge your private community or public cloud into on-premise type of services, or you combine one or two of them. All right, finally, we're going to move into the service models. We have basically infrastructure as a service, platform as a service, and software as a service. Now, this is expanding, right? And some of the other things that are included might fall into one of these other general categories here, right? So, I mean, you could almost say, hey, everything is a service now, right? We have so many different things out there that are basically built off the cloud, and they could span each one of these service models themselves, right? But typically speaking, I'll go over some examples of each one of these. And so we can identify, but we've already kind of talked about one, again, that we're using right now, software as a service, Zoom, right? So that's a perfect example of software as a service. And then finally, when we get into the service-oriented model, there's different levels of control. So when you deal with levels of control with the modern cloud computing versus traditional computing, if you think about if you're managing your own resources, right? You, right, we're responsible for the application, the data, the runtime, the middleware, the OS, the virtualization, server, storage, network. You are responsible for all that. When you start moving certain services to the cloud, right, it ends up being one of those things that there could be shared responsibility, or the provider could be solely responsible. So when we start moving over to infrastructure as a service, we're talking about now, instead of you worrying about that hardware, worrying about if you have that Dell server, that HP server, you don't worry about that, right? You just worry about installing your OS on there, your middleware, your runtime components, your data, and your application on it. The cloud provider handles the virtualization aspect, the hardware aspect, the storage, and the underlying network, right? When you're talking about platform as a service, we'll cover that again, what some examples of that. Your scope of responsibility decreases even more, right? Where you're just worried about your application, your data, and then the cloud provider is kind of responsible for keeping the rest of this up and running, right? And then finally, with software as a service, again, with Zoom, pretty much you just click, get a button, and you use the software, right? So that's kind of where we're at now. Now, there's always going to be a little bit of, end user responsibilities, right? For any type of software you have. For example, with Zoom, right? Zoom bombing was a big thing, right? Like it was one of those things where people were getting Zoom IDs and they were jumping in on other people's conferences or their phone calls, and they were doing malicious stuff. Now, there's protections in place that, Zoom has said, hey, do this, this, and this to protect yourself. And that is still on you. It's your responsibility to know how the software works, right? They can't tell you how the software works, right? But overall, everything else is in control of the software provider. So again, just kind of emphasizing more that, we kind of break down into those three general categories. But when you look at the service-oriented model, like pretty much anything out there now, as new services spin up, end up being almost categorized as their own thing. Function as a service, backend as a service, blockchain as a service, artificial intelligence as a service, databases as a service. And these can also kind of, a lot of these also kind of fall into maybe the platform as a service category, but they can also kind of be given their own designations, really kind of depending on their use case, right? So a little more on the characteristics that define infrastructure as a service, right? So resources, going more into what IaaS is, resources are available as a service. Again, your server hardware, your cost depends on the consumption, where I was talking about it's a metered service. It's highly scalable, meaning you could spin up 1 or 100 or spin down 100 to 10 really quick. Allow multiple users to have access to a single piece of hardware. So that's the back end we don't necessarily see. We don't know how Amazon, we don't know how Azure is divvying out those hardware resources to the consumers. We just don't know that. We know that somewhere, somehow, we're all on the same piece of hardware. Again, unless you have one of those true private clouds where you're the only ones there, okay? The organization has complete control of the infrastructure, and it's basically dynamic and flexible. Some examples, right, of IaaS service. So Microsoft Azure, the overall cloud of Azure, right, is one of its main functions is to spin up virtual machines. Same thing with Amazon Web Services, Google Cloud Provider, Rackspace. Somebody might yell at me for saying that some of the smaller ones that aren't as prominent, DigitalOcean, right? So there's a bunch of different ones out there. And for you, before you move to an IaaS solution, you should really evaluate what your needs are and what they can offer you, right? A DigitalOcean isn't going to have as much flexibility and add-on services as, say, Amazon, Google, or Microsoft. It's just a fact. Characteristics that define PaaS, right? Platform as a service. So we've seen a lot of ground with this particular service. Resources can be easily scaled up and down as your business changes. That's kind of the same as IaaS. That's just a benefit of the cloud. This is kind of the key highlight here. Provides a variety of services to facilitate the development, testing, and deployment of apps, right? So this is kind of really just changing how quickly development can happen, right? And how the software development lifecycle is being streamlined, right? Because historically speaking, in the past, when developers got to developing, right, they would have on their laptop, they would have their own little program. Any developers on the line here? Anybody want to raise a hand and say you're a developer? Own up. Well, I think one of the most famous things that ever comes out of a developer's mouth is, it works on my machine, right? Well, yeah, that's because they were sitting there, they were coding to get it to work on their machine. Now with platform as a service, they can work together as a team and they code it to function on the cloud, right? Or they code it to function on it doesn't matter what system that they're actually on, okay? So I think that's really the strength of platform as a service. So now we're spinning up resources, especially Azure is probably the strongest in this space, but spinning up resources to build apps, make updates to apps, test apps, and finally deploy them faster than ever, right? And the benefit there is, again, multiple developers / users have the same access, the same tools, and it kind of makes it a lot easier to get things built. So some examples, the SAP Cloud, Microsoft Azure. Again, Azure is a suite of services, so I should probably get more, but they have like on-demand applications you can build right there. Heroku is kind of weird. That's certainly a platform as a service that facilitates the deployment and orchestration of containers. We'll cover containers in a little bit. AWS Lambda, again, another type of software as a service to help deploy. Google App Engine, and then another lesser known one called Wasabi. All right, and finally, characteristics that define software as a service. And again, I'll mention Zoom. We're on Zoom right now. Teams is another one that's gotten a lot of visibility recently. HubSpot is for basically it's a CMS. It also hosts websites. There's tons of different website hosting providers. It's amazing to think that, back in 2005, if you wanted a website, you had to get onto a notepad and start, typing things in. And now it's just combined. It's a drag and drop process, right? So it's pretty amazing what the cloud and software as a service has evolved into over the years. Basically, and with the software as a service, hardware providers providers are responsible for everything, right? So again, another quite characteristic and benefit of a software as a service. So what are you looking for? What do you need? If you're not already in the cloud, you got to kind of maybe eventually make the move to the cloud. I mean, everybody says they want to fight it, but realistically speaking, it's happening, and COVID has forced it to go even quicker, right? There's been a boom of cloud services spun up in response to COVID. Businesses are starting to realize the benefits of not having hosted infrastructure anymore. I mean, if your email is still on Exchange after the recent attack, and you're not on Google's platform or Microsoft 365, then that's probably a mistake, right? Because it's just, I think Microsoft did that on purpose, right, to get people to move. But you have to really kind of evaluate kind of what you need, what your end goals are, right? If, for example, you have, like, say, one server at your site, and then you have a bunch of developers making software. Well, you're not going to necessarily need to spin up a server in the cloud, right? What you can do is probably just spin up some sort of platform as a service, right? And then that's going to cut your costs, your heating, your cooling, your electricity, all that stuff. If you're the type of business that you're like, man, we don't really need a server, right? But we need some certain services, what's available to us, then you start looking at software as a service, right? So you got to really kind of measure, your needs, what you can afford. Is it cost effective? Is it going to make sense for your organization? And finally, I have Dockers here as far as, or I'm sorry, containers as its own little special thing, because it kind of disrupted a little bit the model of, the software as a service, infrastructure as a service, software as a service. Because if you look at it, there's still kind of like little machines, but they're machines that have a very specific purpose, right? And it takes us back to that original, hey, one server, one service mentality, right? So it's virtualizing the operating system, and rather than really kind of relying on, say, like a Windows or Linux. Most of them are running Linux in the background, but they're supposedly really kind of locked down, where it removes a whole lot of this, the guest OS, the hypervisor, the host operator, but from access, and it really kind of limits it down to this, so that its really sole purpose is to run an application, right? Get an application up and running, get it up and running fast, and supposedly secure, but we'll talk about that in a little bit here. So now that you kind of have an understanding of all the, the cloud, and I'm sure everybody does, so hopefully nobody's like, oh, I already know all this stuff. Why are you talking about this? Again, it's important to kind of know the history to know where you're going, right? So if we look at the top cloud providers, right, we have a couple of them different listed here, but where we really want to talk about the major players in the space, it's going to be Amazon Web Services and Microsoft Azure. Amazon, amazingly enough, like they were the pioneers of this, right? I mean, you wouldn't think that they would, something that started off selling books, right, ended up being like the largest cloud provider in the world, but they have, right, and they've done a very good job at it. Some people would argue that the interface is not as nice as some of the other platforms. Well, that's because these other platforms came after them and built on, feedback, right? So if we look at the different user market, the user share, we see AWS obviously leading the way. They had a big jump on it from the get-go, but we also see that Azure is coming in, really kind of gaining ground on them, and I don't know if that's because Microsoft's offering different services, or if they have a different marketing model, prices. And finally, surprisingly, the one that is really kind of lagging behind, the Google Cloud, right? Even though they're the ones who, kind of coined the term back in 2006, it seems like they're kind of struggling there. So, and if you're in China, Alibaba Cloud, right? They basically, and the reason they were able to facilitate this is everybody kind of suspects that they basically stole the Amazon model, right? So there are other couple of outliers like VMware, again, surprising, kind of slow to that space. A lot of the cloud providers on the back end, well, probably AWS, a couple others might use VMware to help facilitate. And IBM Cloud, again, is another kind of one that's kind of lagging behind. There's more, there's others out there, but really the two main in the space are Amazon and Microsoft Azure. And again, while you're evaluating, right, the cloud, it's important to note, what levels of compliance they actually adhere to, right? So these are the ones kind of that are important globally in the US. There's another one upcoming that, we're still receiving data on, and it's, I'm sure everybody's heard the term CMMC. And I don't know of any, like, there's specific government instances that supposedly adhere to CMMC, but I don't know off the top of my head about the security that, or the instances that some of the major providers are going to be offering as far as CMMC. But if you look, they're saying that the cloud providers are saying, hey, if you move into our infrastructure, hey, we're PCI DSS compliant, right? We have a SOC 1, SOC 2. We adhere to the Family Educational Rights and Privacy Act, which is kind of an interesting one. We adhere to HIPAA, right? So there's specific, and what they're saying is that their infrastructure, the portions that they are directly in control of, are under compliance for these standards, right? That doesn't mean that you don't have to worry about anything. That just means that, hey, we've had our systems checked, we're good to go. It's up to you to have your systems checked and make sure you're good to go. We'll cover that in a little more in depth here in a few minutes. Okay, kind of moving on. Again, I mentioned the government instances. If you are, quote unquote, a government entity, or even in some cases do work with the government, you may qualify for a specific government instance where you have AWS say, hey, I'm with the government, they provision you, there's a whole long checklist of things you have to go through, and then they provision you a quote unquote government instance that is supposedly very private, right? Same with Azure. And again, I haven't really researched some of the other players, but I don't know if they offer secure instances that are private, but a little more research, again, depending on what your goals are. So with the cloud, keep in mind, it's not secure by default, right? It's your responsibility to maintain the security. So again, when I say, oh, well, you can't just go, oh, Amazon's PCI compliant, I'm all set, right? No, you still have business processes, you still have objectives, security initiatives that you have to meet in order to make sure you're secure. It's not magic, right? Let's kind of take a look at, an example of when the cloud might go bad, right? And I ran into this recently. I ran into this scenario that basically, oh, well, we're in the cloud, we're good, right? Well, yeah, you're in the cloud, but you also have open access to your cloud because of COVID, where you opened up RDP, you opened up SSH, and you didn't put any additional controls in there, right? So what does that mean? You just increased your attack surface to the public cloud tenfold. Like, everybody in the world can now query your RDP port. Everybody in the world can now query your SSH port. So again, the cloud is, when you first implement, if you do everything according to their infrastructure and you plan it out, yeah, you're going to have a good, safe level of security. But if you start turning things up or trying to integrate other services, you have to really be aware of what you're doing. So, we'll go over some more examples on, Jesse's top 10 for securing the top tips, I should say, for securing the cloud here in a few more slides. But be very, very careful, right? So that brings us to, why not Nist, right? Why not, like, everybody's like kind of scrambling to try to figure out, well, how do we secure the cloud? How do we secure the cloud, right? Well, I'm going to say, just take what you already do and apply it to the cloud, right? It's not, Nist framework is perfect just because, and obviously there's going to be a few other things to consider and a few other benefits of moving to the cloud versus having it local, right? And that Nist is going to say, well, you need to do this, this, and this. Well, since it's in the cloud, that's already kind of done for you, right? So we should all be familiar with the Nist cybersecurity framework, I would hope, or if you're not, we'll cover it kind of briefly right now. So we're going to focus on really the core Nist functions. The Nist cybersecurity framework describes these 5 functions that work in tandem to help organizations protecting the digital assets. Once we kind of briefly go over these, we're gonna see how in terms that these can be applied to the cloud, okay? So identify, establish visibility into organization's systems, users, and assets to understand and quantify risk. That seems pretty straightforward, right? Like, why can't we could do that in the cloud? We do it on regular infrastructure, we could do it in the cloud. Protect, implement safeguards, offensive controls, and training to limit or contain the impact of cybersecurity incident by adopting a strong security posture on an ongoing basis. We can certainly apply that to the cloud too. There's a lot more tools in the cloud that are going to help us facilitate that. Detect. Detect, respond is probably one of the things, even with modern infrastructure and closed systems, on-premise systems, that people still don't really have any clues, but using the cloud, to detect activity, engage in threat hunting, and also to be able to respond to any type of incident you might perceive in a timely manner is going to be, one of the most important things when you're operating in the cloud. And then finally, recover. Recover is an interesting concept when you're talking about cloud technologies, right? Because you really have to worry about a adverse event, right? Meaning that somebody went in there or somebody did something that maliciously destroyed your systems, right? Or because if you, and we'll talk about, I'll mention this again in a little bit, but if you talk about the cloud, right, one of the powers of it is that there's supposedly uptime, 99.99999% uptime, right? So a little more on that later, but let's kind of look into the Nist core functions and how we might work with these to secure your cloud instance. So identify, get visibility to all accounts that a user or robotic, or even like a robotic identity, right? There's tons of different AI services, service accounts that have access. So you want to get visibility into all these accounts, right? Also, any type of privileged accounts, right? So when I'm talking about mainly with these, you have to take into account the cloud control panels, right? When you first sign up for a cloud instance, you have, or most users are designated with Amazon, and especially early instances of Amazon, you're designated as a root user, right? Well, the root user has the ability to do anything, right? Anything on that cloud, right? That account shouldn't be used. It should be used by anybody. It should just be put aside if you had it, if you originally provisioned it, if you had keys associated to it. We'll talk about it more, but put it aside, right? But you have to be aware of it, right? On the same side, right? Say you have a lot of infrastructure as a service. Say you have a lot of Windows servers that you ported over to Amazon or Azure. Do another thorough review of your identity accounts on there, your OS user accounts, your admin accounts, right? That still applies, right? Even in on-premise and in the cloud, right? So really the only major change between, on-premise is this, the cloud control panel. That's another threat, right? Your cloud control panel is a huge threat to your organization, and access to those should be controlled. And we'll go over Jesse's tips for, kind of securing those. Next thing you want to do is kind of examine, like when you start throwing all this stuff up in the cloud, you spin things up, you have hooks into it. You want to identify the servers that have relationships with one another. You want to identify, automation things, right? You want to make sure that, hey, yeah, we have this monitoring server, right? And that's up to date. Or we have a Confluence server, or we have a Redis server, or we have a Jenkins server, right? And all these are used for kind of automation tasks. We want to know how these servers interact with our other critical infrastructure up there, right? It's important to know this because if one of those gets compromised, you want to make sure it doesn't lead to compromise in any level of the cloud, right? And again, just to emphasize, automation accounts are usually a high value target, right? Meaning, okay, if somebody were to able compromise, say like a monitoring server, a deployment server, something like that, and they got access to a service account that was storing credentials of clear text. One, people aren't monitoring that service account, right? They're not necessarily like, they don't know when, like if I'm an admin, right? And I log into a system and I go, oh, why is that file on my desktop? I didn't put that there, right? I'm going to know something's amiss. But if you're able to hack a service level account that has higher level privileges, and nobody's logging into a service account on a regular basis, right? So, identifying these accounts and categorizing them is like one of the best things you do to protect your cloud infrastructure. Okay. Again, moving into like the Nist cybersecurity framework, right? We talk about asset management. Now, this is really interesting, right? Because previously, you look into asset management and you have the need to have an inventory control of all your laptops, right? Of all your servers, your networking equipment, right? Well, when you move to the cloud, you don't have to have, you're not responsible for keeping track of that. That's the responsibility of the cloud provider, right? You are responsible for knowing your assets of logical devices, right? But you're not responsible for knowing the hypervisor host, the OS version it's running, how much RAM is associated, all that stuff. You don't need to know that. You still need to keep track of your virtual servers, any other services you might have. The key thing to note here is the core elements of your cloud are not visible. You cannot identify what needs to be done to secure them. And I love this down here, right? And when you want to talk about knowing your assets, the Nist cybersecurity framework. So University of North Carolina, and this is an older like little tidbit, this happened many, many years ago, but they had a Novell Networks server, right? It shows you how old it is, that it's been running great for years, right? And then finally they were mapping out their network. Nobody could find where the stupid thing was, right? So what ended up happening? Well, they ended up tracing it back enough to where they found the wall, and the wall seemed to have been a little weird. Come to find out, a contractor at some point, they were doing work and they covered up the server room door. So again, they definitely didn't have a good logical tracking of any of their assets. But with the cloud, one of the nice things is you have that cloud control panel. You have an inventory area that you can see everything that's up. And the other thing is you're getting charged per asset, right? So you want to figure out what you're getting charged for and why, right? So it gives you a lot more visibility as far as to and the ability to identify. I'm not going to go into these subcategories too much. We should all kind of be familiar with these, but some of these are kind of covered, right? Especially if you move into the cloud where they already have certain levels of certification. Risk assessment, same thing. They offer some type of controls already in place, and risk management, right? You still have to do all these activities, but there's certain things in the cloud infrastructures that help you plan and document. As far as achieving your identity goals, I'm going to kind of call out like a couple of different programs for the major cloud providers, right? Amazon, whoops, I kind of messed that up. Well, Amazon has the Access identity management service. So does Azure. Azure has the Microsoft Identity Access Management service. They also have the Azure Security Center. Again, each one of these has like very similar sets. They're just kind of named something different, right? And obviously the tools are different per AWS and Azure. Okay, moving on to the protect portion, right? Again, it's important to maintain the principle of least privilege by starting with zero trust and assign access based on what's needed. That still applies, right? Why wouldn't we do that in the cloud? Conduct regular access rules. You can use those tools like the access management, identity access manager to help you facilitate that. Right size access privileges on an ongoing basis, remove unused accounts and entitlements. Again, the same things that you should be doing on your on-prem network should be happening on the cloud. And finally, enforce best practices around identity management and authentication, enable multi-factor authentication, deploy single sign-on, stipulate password policies, and enable adaptive access control. There seems to be this push, and I suggest everybody get with it, right, is where we're moving away from passwords, right? Passwords are basically have already been proven to not be the best, right, thing to have in your organization. What's probably going to end up supplementing is some sort of biometrics, right, or other type of factor, right, proving who you are, not what you know, because anybody can know your password. That's been proven. So things like your phone scanning your face and allowing you in. Microsoft is pushing for this big with identity-based access. So it kind of goes along the line, and I feel like that's something that's going to be getting a lot of attention, and that's going to kind of be where we are. It's going to be identity-based, where you're looking into your computer and it's saying, oh, hey, that's clearly Jesse. I'm going to let him in. We already do it with phones. We already do it with phones. Obviously, masks have made it a little bit of an issue when you're out in public, right? But it's probably the best way to go as far as protecting your users and access to your systems, right? I had that in there twice. Some of the protect subcategories, again, really, you still have to do awareness and training. I think that's key for one of the things I'm going to mention again is don't just tell an employee who's been working 15 years on your site, oh, we're going to move to the cloud, right? And expect them to figure it out, okay? These things are these complex beasts. Get them some training, hire additional staff to manage the cloud. Don't just assume that the person can figure it out. My cat just jumped on my head, everybody. I don't know if anybody saw that. Little bugger, one of the things from working at home. So don't assume that your employees are just being handled, right? Give them the opportunity to learn. Don't go at it full blast until you're absolutely ready. Protect achieving the goals of, everybody should be familiar with this, the CIA triangle: confidentiality, integrity, and availability. And how can the cloud really kind of help us to achieve these goals? Well, almost the same way that it currently has, but it has, it gives us the ability to implement things a lot cleaner, right? The availability, right, is obviously achieved in the cloud a lot easier. They have these things called zones and regions, right, where you have data centers that can automatically replicate or repoint traffic on failure. And these data centers and these zones, these regions, are literally all over the world. So if there's a hurricane coming up the East Coast, Category 5, like we had a couple years back, and it flooded New York City, hey, you're going to have another data center that's ready to go on the West Coast, right? If a big earthquake comes and takes out the West Coast, we have data centers on the East Coast. We have data centers all over the world, right? And it just really depends on your organization, your compliance, what you pay for, right? How data encryption is achieved, right? Protecting your assets, data encryption. You want to look at things specific for AWS, Elastic Block Store, EBS encryption, S3 encryption, transparent database encryption. That's not a new term, but there's certain ways to do it. VPN gateways, right? Making sure you have VPN access, VPN tunnels. Managed keys, that's interesting, right? Especially in the Amazon cloud platform, there's a lot of different managed keys. We could also refer to keys that are used to secure communications in remote sessions, right? And I highlight the term manage here in bold, right? Because with a key, managed key, it's not any good if you send that key over email, right? It's not any good if you like randomly lose this key and you don't know where it is and you're like, oh, I'll find it later, right? You have to have a record and account for them and who has access to them, because when you're talking about keys in the cloud, they could actually be the keys to your kingdom, and compromise would be really, really bad. Let's look at some of the different services that we talk about with Azure when you're dealing with data encryption, right? Azure SQL, BitLocker, Cosmos DB, Data Lake, again, VPN, encrypted VPN tunnels. These are all protecting your assets at rest and in transit. And finally, kind of managed keys. So next, I kind of want to highlight what happens specifically in the cloud when you fail to identify and protect your assets in the cloud, right? And map things out and have good solid control. If you guys look up murder in the Amazon cloud info world, it's surprisingly an old article, but it was also kind of right when AWS was gaining prominence, right? There was a company called CodeSpaces, right? CodeSpaces was very similar to GitHub, right? I'm sure people have heard the term GitHub repositories. The nice thing about GitHub was about 3 or 4 years ago, Microsoft bought them for like $8 billion. Well, CodeSpaces had a very similar model of software repositories, subversions, things like that. They thought they were solid. They had everything up in the cloud. They had some backups, right? Well, you know what they weren't doing? They didn't go and they had that one root control account, right? They had that one root user that had full access to their control panel and they shared it, right? Well, somebody's computer got hacked. A hacker got control of all their resources, right? He said, hey, go ahead and give me this. And I think it might have been cryptocurrency at the time too, which is kind of funny because that, again, it was quite a few years ago. And he said, hey, if you try to regain access, I'm going to destroy everything you have. Sure enough, they tried to regain access. He wiped everything. So all their customer data, all their data, everything was gone. Now CodeSpaces, they're like, oh, hey, no, it's fine. We have backups. Guess what? Their backups were on the same exact cloud system as everything else. There was said the control panel had full access. The hacker wiped that. It's CodeSpaces, guess where they are? They didn't get bought by Microsoft for like $8 billion. They're gone. They died that day. So literal murder in the cloud because they ported their stuff to the cloud. They assumed they were secure. They didn't do any of these checks. They didn't adhere to any type of frameworks. They just thought they were good because they were in the cloud, okay? So what happens when you fail to identify and protect your resources in the cloud? All right, kind of moving on. I know I don't want to talk more than an hour because I feel like people start falling asleep, but hopefully I'm keeping everybody awake. So detect portion of, how do we apply this to the cloud? Kind of the same way we apply it anywhere, establish continuous observability of activity across cloud services with context around which identities are performing the actions. Really key, right? Like I said, you're going to have those identity management. Certain accounts should be doing certain things. Service accounts should be doing certain things. A service account might not necessarily need to log into a domain controller or another server, right? If you know all this by identifying, then you'll be able to know how to detect, right? So you detect account takeover, insider threat based on normal analytics, conduct threat hunting, on that. Again, the subcategories, I'm not going to really go into those. It's all could kind of be lumped in here. But how do you achieve these goals of detecting? I'm putting an emphasis on advanced threat protection, managed detection response, and EDR solutions. Okay, this is how you protect yourself. This is how you detect. This is how you identify. This is how you mitigate. These types of solutions that are out there now. There's so many different products that are going to get a lot of buzzwords. I wouldn't necessarily trust the cloud providers. Another thing I'm going to say is, hey, yeah, the cloud services have their own versions of things. Mix it up a little bit, right? Don't go, oh, we'll use our service because it's already here, right? No, go out layers in depth, right? That old term, defense in layers, and things like that. But just so you know, AWS has things like Amazon Guard Duty and CloudTrail to help you detect and look for things. Azure has Microsoft Defender for Identity and Azure Sentinel. I recommend a product that two different products. One I really recommend is Sidenet 360. It's agent-based, you deploy it, and it does all this type of managed detection response where you're, it'll look at these types of tools like CrowdStrike. They'll look for activities like that. So, hey, that user account just logged into 10 servers. Why is it doing that? It didn't do that before ever, right? And then that allows you to respond. Or it even has technologies built into where it can respond for you, right? It goes, oh, hey, I just saw this account do this. This isn't normal. I'm going to lock it out, right? And then it takes you, an administrator, to go in and manage that, right? But those also come with their own concerns too. What if somebody compromises your managed detection response system? So a lot of things to consider. It's a never-ending battle. So respond portion of Nist, we're gonna cover that, but it's also an add-on to detect. It's all kind of melding into one. You're gonna have one. There's tons of different tools out there, but you have to also be aware that now not only are you have to become familiar with the cloud and its entire infrastructure, right? Where we used to have segregation of duties, you're almost finding that you have like DevOps teams and administrators of these platforms, which are responsible for provisioning of servers, the networking, right? And these are all things that they typically didn't have to be responsible before. So very scary, where you have added responsibilities onto people where they might not have the training. But, and then on top of that, you give them these tools to kind of detect and manage. And now it's like, oh boy, now I gotta learn this tool. But when you get tools like MDR and EDR, you basically can set them up to do a lot of the heavy lifting for you, right? You still need to have a team monitor and set up procedures in support of these activities. And finally, recover, right? Recover, this is really kind of, so when we're talking about recover in the cloud infrastructure, we're really talking about adverse events, things that cause corruption of data, deletion of data, much like that code spaces example. Because the recover, yeah, you could have backups, but you're only gonna really go to your backups if there is some sort of malicious event normally. Because as far as downtime goes, we've learned from if you deploy, you could have that 99.999% uptime, right? But if you're not really properly detecting and discovering issues in your environment as a result of threats, you're not gonna have that complete picture to fully restore and recover your services, right? So it can be different with every incident. Know that the cloud services, they have fast replication, fast storage, the ability to port services, halfway across the world quickly, right? There's different tooling that you have to look at, different programs to kind of really look at, and these really depend on your business and the model that you're going after, and those tools need to be secure and protected. So finally, we're going to move into my list of things that you could kind of do to protect yourself, to protect your cloud, right? Two-factor authentication, MFA, on everything you use, everything, every service you use, MFA. I don't know. I think Zoom, does Zoom have an MFA? If Zoom has MFA, yeah, it does actually. I think it does. Yeah, sign up for Zoom MFA, sign up for email MFA, QuickBooks MFA, Azure MFA, AWS MFA, MFA on everything, every single thing. There's no reason not to do it. All right. It's got to protect you. It's got to protect you against, so you getting those credit alert. Oh, your data was found in the dark web. One of those passwords used found in the dark web. MFA for everything. Second, if you're in AWS, no root access. If you have it, I believe the newer instances of AWS, they don't have root by default, or they have controls in place as soon as you set up your account to spin it down or back it up and secure it. But if you do need root access, if you do need keys to help you manage, store your keys on encrypted machines, never send those via email. Don't send them via Teams. Don't send them via Zoom chat. Don't send them via Slack channels. Nothing like that, okay? Set expiration, rotate them out periodically, right? This other one's great, right? Protect your code repository, right? There's hackers right now, they have bots. It's searching GitHub. It's looking for AWS keys that were pushed up with code, boom. And then if your GitHub is public or not protected, they now have access to your cloud environment, okay? Start looking at zero trust access, right? Zero trust networking, things of that nature. Limit service accessibility to whitelisted sources. For example, we at Compass, I have a server in the cloud that we use for penetration testing. It does have RDP open, right? It's just something that we needed to manage RDP. COVID, we need to open it up. It's whitelisted. Only the IPs I specify can gain access. Okay. Same thing with SSH. Partner with companies like Cloudflare, right, to protect against distributed denial of service attacks. There's other places out there. Imperva is another good one that provide denial of service protection. Even though I said do not open remote access services, if you do have to, make sure they're whitelisted. Opt for a VPN instead, right? VPN protected by what? Two-factor authentication. Secure SSH with key-based management if open to the public, meaning if you have SSH, don't rely on passwords, rely on keys. And then have someone go on the offensive. We'll talk about that right now. A lot of times our customers are like, oh, we're in the cloud. We'll get a pen test internally. We don't have to pen test internally. I'm like, that's nonsense. I'm like, what do you mean? Like, you have to validate that controls are in place and that they're working. So the insider threat in the app is still an issue, right? Let's take a look at this following scenario, right? We have two different, these are Amazon virtual private containers, VPCs. So each of these are segmented out, right? There's no access between these two, right? There is a way though, however, to establish a connection between these two, right? Well, why does this happen? Well, somebody could have something on here, like for example, this could be a dev instance, this could be your prod instance, and the developer, right, needs to push something from dev to prod, right? DevOps team or whoever might be in charge at that time, they got a VPN to this instance, right? They set up this VPC pairing connection. Now you get a full tunnel between these two, between your dev and your prod, right? Okay, well, the developer goes, oh, hey, yeah, I just pushed my Jenkins over here. This is great, all set. I'm gonna go about my business, right? Never has the afterthought of, hey, man, that was really convenient. I'm gonna have to do that for the next build or next month when I do a next build. They never really think, well, maybe I should close that down, right? Have proper segmentation. I think that was one of the things that they said from the gas pipeline recently is they found out that they didn't have proper segmentation. Same thing applies to the cloud. Next thing you know, the developer is about his business, maybe gets on an email. Oh, what's that guy? Little skull? It's probably not something any good, right? And all of a sudden, that little skull is going from dev right into prod and owning your entire cloud network, right? Scary, scary stuff there, right? So internal cloud resources, segmentation controls, review of such controls are important. Have a third party do it, right? Don't trust that you did it, right? I never trust myself. I make mistakes all the time. External pen tests, still a major, major thing to do. If we look at this example here, I did this search right before this little session here. This is at least 71 servers on AWS that allow anybody to hook in to remote desktop protocol port 3389. Craziness. You can even say, hey, oh, this is my AWS instance. It looks like it's a Windows 7 machine, right? Brute force attack, maybe because they put MFA on, right? Here's another example. Over 1,061 ports available here with Redis. Redis is, database type services. 1,061 all on Amazon, some flavor of Amazon. Open. External pen test required of those services. Absolutely. Also have your public facing websites hosted on Amazon. Evaluate against the OWASP top 10. So all these still same things apply, right? We still talk about secure. We still talk about making sure things are secure. These are all the different steps you have to do probably on a yearly basis to make sure that you're secure. APIs, same thing. Protect access to APIs with whitelists. Scan for API weaknesses before you deploy and open them up. Implement WAFs, web application firewalls. Cloud services have WAFs. They're not as expensive as they historically have been. They have basic services. They protect you against the OWASP top 10. And then finally, containers. Containers are interesting, and I said I would mention a little more about them. Some of the benefits of them, greatly reduced attack surface, right? There's no like OS level to attack necessarily. They're fast, reliable, spin up. Heroku can deploy hundreds of them in a matter of minutes, right? They do have their own problems. They need to be evaluated too. You can't just go, oh, well, Amazon says it's a secure container. Azure says it's a secure container. Oh, this GitHub repository says it's a secure container, right? Let's take a look at some scan statistics of some containers that are available. Let's take a look at that one. Kubicon checks over 645 open vulnerabilities, right? And these are all different containers. Debian FTP, nothing on there, that's good. AWS Monitor, S3 simple resource. So with 29 different vulnerabilities identified in that, right? 38 on this caddy. And these are all ones that are, could be pulled. ECS agents, ECS sample. These statistics are a little bit older, right? But don't rely on them 100% to say that these little containers are secure. And don't go on GitHub and pull containers that you don't know anything about. And I think that's it for our presentation. And I hope you guys kind of found that informative. I hope it wasn't too boring. Does anybody have any questions?
We did have a question.
Sure.
For third-party risk assessments, are there some standard questions to ask the vendor regarding each of the cloud providers, like the AWS, Azure, and Google?
Yeah, you wanna ask them kind of what. I mean, it depends overall what your objectives are. You definitely want to ask them about. I was going to go all the way back to compliance, right? But you can ask them about, hey, do you have a SOC 1, SOC 2? Are you PCI compliant? Things of that nature. Another interesting thing that you might want to ask them is, hey, who has access to the data center? Physical access to the data center. That's a big one, right? Amazon claims that they have like this whole written policy that, oh, if physical personnel need to get in there, they're highly vetted. It's controlled per person. Requests need to be made a week in advance, and that's only for like Amazon employees. It's like you can't just have normal Joe Schmo go in there, right? So those are kind of some of the questions you ask. Availability, right? As far as, hey, does this particular region secure? Does it fail over? Where does it fail over? Does it have the same type of security as the region that I'm in? Government instances are other things that you'd want to kind of have a little bit of clarification on. Another one that might be like, hey, is this data center GPDR, right? Like it has been certified, right? Because that instance might not be, but you might be doing a lot of business in Europe, right? From Europe. So things of that nature. Hopefully that answers your question.
I think so. Will these slides be available?
I can make them available. I'll send them to Isaka.
Okay, and we did just get another question. Hold on. It is, what types of configuration questions should be asked, like access, encryption, etc.?
That's kind of a tough one. Basically, you want to see what ciphers are supported, what's the key size. Pretty much anything that you get on the modern cloud is going to have the industry recommended standard, but it's always good, depending on the service that you're interested in, to go look at the specifications right there. They have them all kind of listed right out depending on the type of service.
Okay.
Awesome.
All the questions we have at this time. Yeah.
Great. Well, I hope everybody found that informative. If you need any assistance from me, I'll throw my email up in the chat right now. Well, I'll throw it to the host, and then she could distribute it out here.
Sure. Hold on. Oh, here's a question while we do this.
Sure.
Is there a checklist or a guide available for control testing?
Not officially, right? Different auditors, different places. There's not like a one-on-one checklist now. If you kind of follow the cybersecurity framework, though, you might be able to kind of build your own. There's supposedly a new framework coming out that will provide a checklist, but who knows if it's going to get fully adopted. Certain companies have built auditing of said checklists out there. I could give you guys a sample when I'll send it to Isaka right afterwards. there's not one standard checklist that I kind of found, because there's just so much to kind of look at within the cloud, right? So it's like always kind of like a general overview, but most of the emphasis on checklists come from identity and access control, like what I was saying with root, is MFA enabled, do the accounts expire? So those checklists are usually kind of primarily centered around those activities.
Okay, we have another question. What are the top 3 cyber mistakes that organizations make while adopting the cloud?
So one would be that the account access thing, right? That's probably number one. Number 2 would be that whole theory of garbage in, garbage out, right? Basically, when you have infrastructure already on hand in virtualized format and you want to port that over to the cloud, and then you realize that, or you don't realize that, while it was hosted on your infrastructure, you had all these different open ports and services, right? That weren't really meant to be there. And next thing you know, you're porting it up in the cloud and something breaks as a result. So what do? You lessen security controls to get your service up and running, right? So that's, poor control. And then third is just that, like the unmonitored configuration changes, kind of like what I was talking about in this example right here, where you had somebody open up something, unmonitored configuration change, going, oh, hey, why there should have been a change control in place for this, right? And then it should have been reverted back when the person was all done with that activity.
Great. Do you see organizations lacking in cyber talent? And what are the top cyber training to consider?
We definitely lack so not only are organizations, and I hope nobody takes this the wrong way, organizations lacking cyber talent, they're just lacking IT talent, right? We've historically had IT staff in place, especially when it comes to small and medium businesses, that the IT staff, they're doing their best. They got on there because they were the smartest guy. They're the ones that showed up to the job. They're the ones that can figure out how to use a computer, right? So you layer that on top of now, okay, not only are they responsible for keeping systems up and running, again, I'm kind of focusing more on small and medium companies because that's where the most need is. But not only are they responsible for keeping things up and running, now they're responsible for security. And then, as you know, with the CIA triangle, you have to maintain that availability security aspect, right? And that's kind of hard to maintain when you have somebody who's probably overworked, doesn't have the training that they needed. They just kind of fit into the role. And then now on top of that, they have to worry about somebody dropping ransomware. And the attacks come from, now it's not, oh, hey, there's like some complex attack. Now it all starts with an email. So now your attack surface is everybody that works at the company, right? So general security user awareness training, I think the last statistic showed that about 90% of major attacks that caused infrastructure outage came in from an email, right? And even if you're on the cloud, that email scenario is very real, because if you think about, if I'm highlighting on my desk here, you think about the remote user, they have email access, but maybe they have a VPN connection to connect into the sales database because they're entering in sales, right? They answer an email, next thing you know, somebody's laterally moving up into the cloud, right? So it starts with generic end user awareness training, letting them know that these issues exist, and really kind of starts with email, honestly. So I could amend my last question, say, hey, believe it or not, emails are a challenge still in the cloud, depending on your deployment. That's kind of a long-winded answer, sorry.
That's okay. What cloud computing certifications would you recommend?
So
progression from one certificate to another?
Yeah, I mean, it depends on your overall objective, right? There's not going to be, like, if you go get certified for Amazon, the Amazon cloud, but then you're like, oh, I can only find jobs for Azure, right? That Amazon cloud certification is going to do literally nothing for you, right? Because it's a completely different set of tools to use. So I guess it really kind of depends on your long-term career goals. I personally like Azure a little bit better because of the interface and the usability, and it seems like Microsoft is really gaining ground on Amazon. So if I had to recommend one, if you're interested in getting into that cloud management infrastructure, learning it all, I would recommend Azure. AZ 500 would be the first one you'd want to get.